All right, we are on page 31, lesson 3, section 3, which operations, part 1. Says, Diego and Jada want to scale this polygon, so the side that corresponds to 15 units in the original is 5 units in the scaled copy. So we have 30, 36, 18, 15, 12, 21. Diego and Jada each use a different operation to find the new side lengths. Here are their finished drawings. And for operation, it doesn't mean like they're doing surgery. It means did they add, subtract, multiply, or divide? They're talking about mathematical operations, okay? So let's look on the next page. And here is Diego's drawing, and here is Jada's drawing. And it says, number 1, what operation do you think Diego used to calculate the lengths for his drawing? Number 2, what operation do you think Jada used to calculate the lengths for her drawing? 3, did each method produce a scaled copy of the polygon? Explain your reasoning. So again, we started with this one. And it says, wants to scale the polygons, the side that corresponds with 15 is 5. So they're going from 15 to 5, okay? So how do we go from 15 to 5? Here's our 5 right here. So Diego did make it a 5, and Jada did make it a 5, but operations, adding, subtracting, multiplying, dividing, okay? So the original numbers are 30, 36, 18, 15, 12, and 21. So if we're looking at our addition, subtraction, multiplication, division, I think Diego, well, how do you go from 30 to 20? Take 10 away, take 10 away, 10, 10, 10, 10. I think he did subtraction. So what operation do you think Diego used to calculate the lengths for his drawing? Diego subtracted 10 from each side, okay? And then it says, what operation do you think Jada used to calculate the lengths for her drawing? Well, 30 to 10, 36 to 12, 18 to 6, 15 to 5, 12 to 4, and 21 to 3. So you could say subtract 20, right? It's not getting bigger, so they didn't add. Subtract 20, but 36 minus 20 is not 12, so it's not subtraction. Multiply. 30 times what gives us 10? Well, I don't know, but I know the opposite of multiplying is dividing. So 30 divided by 3 is 10. 36 divided by 3. If you guys don't know, you should have a calculator and you can check these. So 36 divided by 3 is 12. 18 divided by 3 is 6. Oops, 18 divided by 3, not times. 6. 12 divided by 4 is 3. 21 divided by 7 is 3. And 30 divided by 10, back at the start, is 3. So I'm going to say that Jada divided each side by 3. And then it says, did each method produce a scaled copy of the polygon? Explain your reasoning. I'm going to say no, it didn't. The only one that is a scaled copy is Jada's. So no, the only scaled copy is Jada's copy. Okay? It's Jada's copy. And that is 3.3, part 1. 3.4, which operation, part 2. Andre wants to make a scaled copy of Jada's drawings, so the side that corresponds to 4 units in Jada's polygon is 8 units in his scaled copy. Andre says, I wonder if I should add 4 units to the lengths of all the segments. What would you say in response to Andre? Explain your reasoning. So I would say pause right here and check it out and then come back. So hopefully you guys just paused and figured it out. I would say, if I was answering this, I would say, Andre, no, you can't add 4 units. Should I add 4 units? No. When we are using scale factor, we are multiplying. And I know I used division up here, so we could actually change Jada to multiply each side by 1/3 instead of divide by 3. It's the opposite operation though. So you can only multiply. So instead of adding 4, it says Andre wants to make a scaled copy of Jada's drawings. The side that corresponds to 4 units is 8. So 4, he wants to take this 4 and make it an 8. How do we go from 4 to 8 by multiplying? Multiply 4 by 2 equals 8. So he's going to scale factor of 2, which means he's going to multiply all sides by 2. Okay, that's that one. Hopefully you came up with something similar. Turn the page, page 33. Number 2, it says create the scaled copy that Andre wants. If you get stuck, consider using the edge of an index card or paper to measure the lengths needed to draw the copy. Well, what we can do is I'm going to use my Post-its. So I have a Post-it here. We want to scale a copy of 2, right? So we're going to go from 4 to 8. So I'm going to make everything twice as big. So I can mark my first side of being 10 is right here. Come over here. And I'm going to start right here to here. And go down a little bit more. It's not going to be perfect, but it's going to look pretty nice. So that's 10. Take my ruler and draw my straight line. 10 times 2 becomes 20. Across the top is my 12. I need 2 of those because I'm scale factor of 2. So here would be 1, 2. Take my ruler. Connect my dots. This 12 becomes 24. It's multiplied by 2. This 7 across right here, I need 2 of them. So 1, 2, that would be 14. Take my ruler and connect my dots. This is 14. Gotta go up 4. So 4 is right here. So if I want to do another one, I can also do it this way. Take my 4, and then this is my 8, right? So then I know that it's this measurement right here is 8. So I can come up and just draw my point right there. This is an 8. Okay. And then I know that from here to a certain point is my 6. So I can use this corner and do 6, and I'm doubling it. So I actually went 12. 6 plus 6 is 12. Come straight down right there. It's my 12. Use my ruler. This is my side 12, and then I'm going to connect these 2 right here. And in my original it was 5, so it's going to be 10. And there is my scaled copy. So it said create the scaled copy that Andre wants. This is the scaled copy. It's a scale factor of 2. And he wanted the 4 to change to an 8. Done. And everything is properly proportioned. Are you ready for more? The side lengths of triangle B are all 5 more than the side lengths of triangle A. Can triangle B be a scaled copy of triangle A? Explain your reasoning. So I would again press pause and come back to it. Anticipate your answers. So hit pause right there. All right, we're back. So you pressed pause, you worked on your own. I would say that yes, if triangle A is equilateral, then its side lengths are all the same. Adding 5 to each side, the lengths will still be the same, and so triangle B will also be equilateral. If triangle A is not equilateral, then triangle B will not be a scaled copy of triangle A. Okay? So yes, if they're equilateral. Triangle A is an equilateral triangle. Okay? So we're going to pause there, and I'll go over the summary in a minute. All right, so the last part of lesson 3 is the summary. It is on page 33. It says, creating a scaled copy involves multiplying the lengths in the original figure by a scale factor. So when we're talking about scale factor, we're talking about multiplying. So that is the operation that we're talking about. Always, always, always. When you see scale factor, your brain should say, oh, I need to multiply. What do I need to multiply? It's going to be a whole number or fraction. Okay? For example, to make a scaled copy of triangle ABC, where the base is 8 units, we would use a scale factor of 4. This means multiplying all side lengths by 4, so the triangle DEF, each side is 4 times as long as the corresponding side in triangle ABC. So 2 times the scale factor of 4 gives us 8, right? That's where the 8 comes from. And then over here, 1 times what gives us 4? Well, it would be the same scale factor of 4, right there. And then we have the last one, 2.24 times the scale factor of 4 gives us 896, and that's where that measurement comes from. So they're saying that it's scale factor 4 every single time, okay? And that's it.